Did you know the average factory worker ignores over 100 alerts per shift? That's not laziness. It's a predictable psychological response called alert fatigue. Most smart sensor setups accidentally design for this failure. We're going to reverse engineer the problem. So why does a $1 million system end up ignored? Let's go to the factory floor and see it firsthand. Today, we'll see why those expensive sensor dashboards become ignored wall art. Then we'll break down how static systems drown in data. Next, we'll uncover the hidden patterns AI can spot in the noise. Finally, we'll look at the real-world payoff when you get it right. Walk any factory floor and you will see them. Shiny sensor boxes bolted to pumps, motors, and pipes. They cost thousands each. Now walk to the control room. There you will find the real problem. A wall of monitors, each showing a dozen scrolling charts. Data points blink and change color constantly. This is the dashboard. It is meant to be the nerve center. In reality, it is expensive wallpaper. The shift supervisor has not looked at that screen in an hour. He is dealing with a jammed conveyor belt. The engineer is on the phone with a vendor. The data is flowing, but it is flowing into a void. The sensors are screaming about rising vibration, about temperature creep, but the alerts are buried in a flood of minor warnings. They are just more noise on a noisy screen. This is the silent failure. Millions in hardware and software generating perfect data that influences no decision. The sensors are smart. The system is dumb. It collects information but does not translate it into action. It becomes a monument to spending, not a tool for improvement. The real cost is not the equipment. It is the downtime it was supposed to prevent happening right now while its warnings go unread. This is why static dashboards fail. They cannot handle the sheer volume or speed of information, which is exactly what we will break down next. The data fire hose is on full blast. Every second, thousands of readings flood the control room. Vibration levels, pressure differentials, temperature gradients. Each number is a pixel in a massive shifting picture, but the human brain is not built to see that picture in real time. It is built to focus on one or two things at a time. So the operator scans. He looks for the big red alarm. He misses the 5 small yellow warnings that, together, spell catastrophe. This is analysis paralysis. The system provides perfect data at a speed and scale no person can synthesize. The dashboard becomes a blizzard of numbers, a cacophony of beeps. The critical signal is there, buried under a mountain of noise. The team is not ignoring the data. They are drowning in it. They spend their shift reacting to the loudest alert, not the most important one. The factory is flying blind, guided by a stream of information too fast to read. This is the core failure of static monitoring. It assumes more data equals more insight. In reality, more data without intelligent filtering equals more confusion. The path forward is not a bigger screen, it is a smarter filter. But what if the system could see the picture for you? This is where the noise becomes a signal. An AI algorithm does not scan a dashboard. It digests the entire data stream, every vibration, temperature, and pressure reading, as a single continuous story. It learns the normal rhythm of your machinery. Then it listens for a discord. It finds the subtle pattern, a slight increase in motor vibration paired with a fractional drop in coolant flow, paired with a specific harmonic in the bearing noise. To a human, these are 3 separate minor events. To the AI, they are a single sentence. That sentence says, a bearing will fail in 18 hours. This is predictive intelligence. It is not an alarm for what is wrong now. It is a forecast of what will break tomorrow. The AI connects the dots across dozens of sensors, spotting the faint whisper of failure long before it becomes a screen. The red alerts on the old dashboard were the disease. This pattern is the early symptom. The factory floor transforms. The messy, reactive chaos is replaced by a sleek, optimized flow. Bottlenecks clear not with force, but with foresight. The system stops fighting fires and starts preventing sparks. This is the power of seeing the hidden story in the data. The payoff arrives not as a dashboard update, but as a changed reality on the floor. The conveyor belt that jammed weakly now runs silent. The furnace that overheated its batches now holds perfect temperature. The air compressors that screamed at midnight now hum in steady rhythm. This is the ROI, written in the language of uptime and output. Downtime shrinks because the AI schedules maintenance for the bearing it flagged yesterday, not the one that exploded today. Waste drops because the system adjusts a chemical feed valve by a fraction of a degree, preventing an entire off-spec batch. Energy consumption falls because the AI orchestrates machine startups in a staggered sequence, smoothing the colossal spike on the power bill. The red alerts on the old screen were the cost. The green optimized flow is the return. The factory stops bleeding money through silent inefficiencies. The investment in sensors finally pays for itself. Not in data, but in saved hours, saved material, and saved power. The system learns which alerts actually matter and when to stay silent. The factory floor is no longer a place of ignored alarms and silent breakdowns. It is a system in tune where data becomes foresight. The investment in sensors finally pays for itself. Not in more data, but in saved hours, saved material, and saved power. Download our free Smart Factory Readiness Checklist at the link below to see if your facility is actually ready for an upgrade. See how this transformation works for your floor at Storyglider.